Hi, my name is Mohit Srivastav, and I'm here with Paul Yuknovich. We're lead program managers responsible for the Visual Studio tooling and client libraries for Windows Azure. Windows Azure is Microsoft's public cloud offering with data centers around the world. In this video, you will learn how to build a Windows Azure cloud service that is both multi-tier and massively scalable. We'll start with an existing ASP.NET application. Then we'll extend it, test it, and finally deploy it to the cloud. Let's get started. The first thing you need to do is download the Windows Azure SDK for .NET. Navigate your browser to windowsazure.com. Once you're there, click Develop, followed by .NET, and finally Install. What you see here are one-click install options, both for Visual Studio 2010 SP1 as well as Visual Studio 2012. The one-click install contains both client libraries for Windows Azure services such as storage and service bus, as well as tooling for Visual Studio. Also, take note of the last updated date here. We move at cloud speed, and accordingly we update the SDK several times a year. While you can certainly stay on the older versions of the SDK, you should visit this site periodically if you want to grab the latest features. And it's also important to note that you can install multiple versions of the SDK side by side, so you can gradually test out the new SDK and then move your apps over time to the new SDK at your own pace. Once you've installed the SDK, the next step is to decide how you're going to host your application in Windows Azure. You can see the available hosting options by navigating to Home and then clicking on Features. As you see here, there's 3 hosting options available: websites, virtual machines, and cloud services. For this particular video, we're going to go ahead and use cloud services, which are optimal for multi-tier, massive scale applications. Now that we've decided on cloud service, let's switch to Visual Studio. Once you're in Visual Studio, there's 2 ways to create a cloud service: entirely from scratch or from an existing ASP.NET web application. To create it from scratch, I navigate to the File menu, choose New, followed by Project. I pick Cloud in the tree view and hit OK to kick off a wizard. The wizard will help me create a skeleton cloud service. I'm going to go ahead and create a cloud service with 2 tiers, a front-end web role, and a back-end worker role. Once I hit OK, I get a skeleton project created for me. The other way to create the cloud service is from an existing ASP.NET web application. I'm going to now hand it off to Paul, who's going to walk through those steps.
All right, thanks, Mohit. So what I'd like to do now, as Mohit said, is we'll start with an existing web application, and we will enable this application to work in Windows Azure. We'll add some of the tiers. For example, we'll add a worker role tier. We'll enable caching, and then we'll publish this application in Windows Azure. So to get started, I have my photo gallery application open in Visual Studio, and this is an MVC4 application. And what I can do is right-click and use this command, Add Windows Azure Cloud Service Project. This command will add the Windows Azure project, and it will take the first steps in order to configure this web application as a role in Windows Azure. And just so that everyone knows, a role is like a template for a tier of an application that you can stamp into multiple instances or into multiple virtual machines in Windows Azure. Looking at this project, I can load this photo gallery front-end role in our role designer. And the designer exposes a number of interesting properties, both in terms of packaging and deployment, but also in terms of the model that I want to have for this application and its runtime behavior. So I can see the instance count, which is set to 1. That means literally 1 virtual machine. Let's set that to 2. And it's that easy to scale out an application using Visual Studio. And I can reconfigure these settings at a later time if I have more scale needs or less. I also can change the virtual machine size. That just controls the amount of hardware that I'm allocating. And I can do things like enable diagnostics, and I can later configure settings. What I would also like to do is add an additional role. And a role basically will correspond to another tier that I want to add. So let's add a new worker role. And for this worker role, my intent is to do more back-end processing of images. I will use a Windows Azure queue, and when queue messages come in, that's my signal for the worker role to do that processing. I also anticipate having some leftover capacity in this role, so I'd like to actually enable a co-located cache service inside of this worker role to take advantage of that capacity. Let's take the first steps to scaffold what this worker role will do. And this will get us into the multi-configuration capabilities of Visual Studio. So what I'd like to do is make a connection to Windows Azure Storage. To do that, what we'll first do is take advantage of the configuration APIs that are part of the Windows Azure SDK. So we'll type in a new variable here. We'll have a string for our connection. And in the Windows Azure namespace, we have this Cloud Configuration Manager. And we'll use that to get a named setting from a key. And this single line of code, that's all I need to do to load a configuration setting from the cloud configuration, which is preferred, but also it can fall back to the web config or app config that my project may already be using. So the great thing is this one line of code helps you more easily go between on-premise and cloud. Back in the role designer, I can open this up, and we'll define the setting. So I click on Add Setting. We'll type in Connection. And the Visual Studio tools, if I pick Connection String, will give me a nice builder that's helpful to configure this Windows Azure storage connection string. So I have the options to use the local storage emulator, so I don't even need to use Windows Azure resources yet. I can use my local machine. And I could also type in credentials to work with a remote Windows Azure storage. For now, let's use the emulator. And the setting is defined. One other thing I'd like to note is you can define multiple configurations in your project. And this allows the single application definition to target multiple Azure environments. So for example, we have the local development environment, we have test environments, pre-production, and production. I can define all of those environments in this dialog to manage. And for each name configuration, I can have unique connection strings for storage, for secrets, for databases, etc. We also mentioned that I'd like to enable caching. So the way I would do that, I would go to the Caching tab, and I can simply check this box to enable caching. And we can use this slider to decide how much of the role's capacity do we want to allocate to the cache service. I'll stick with the defaults for 30%. At this point, I have the working frame of a multi-tier and highly elastic cloud service application. What I'd like to do now is package and publish this application up to Windows Azure. So to do that, we'll right-click on the Azure project. We'll say Publish. And Visual Studio will pop up a wizard that walks me through the process, and it's really easy. First thing is we want to make Visual Studio aware of your Azure subscription. That's where we will publish to. It's also going to help me provision resources that I need up in Windows Azure. So I've already imported multiple subscriptions into Visual Studio, and we'll hold on to those subscriptions. If you're doing this the first time, simply click the Sign In to Download Credentials button. We'll download a simple file. You can import it, and now your subscriptions are available to Visual Studio. We'll click the Next button, and I can go ahead and target a particular cloud service container. As you can see, I have one that I want to use here. If I haven't already created and provisioned that container, Visual Studio can go ahead and do it for me. Last, we talk about those multiple environments that we want to target in Windows Azure. I can simply pick that service configuration right here. There's a few more advanced things that you may want to do as a developer, and I want to show you those as well. So thinking about diagnostics, one of the initial ways that we do diagnostics is by using Remote Desktop to remote into a particular instance up in Windows Azure. By clicking this Enable Remote Desktop box, I'm going to configure Remote Desktop actually up in Azure. So we'll type in a username and password, an expiration date, hit OK. I can also enable Web Deploy. Web Deploy allows very fast, rapid updates for single instances. But I'm actually going to use multiple instances in this case. And going to the advanced settings, we have additional agents that we can deploy with our application that help us with further diagnostics. So I'll focus on two of them. We'll go ahead and we'll enable IntelliTrace. IntelliTrace in Visual Studio, that's the most powerful way to get diagnostic and debugging information from a remote server. And we can enable IntelliTrace and we can bring those logs down from the Azure environment to our local machine. At that point, it's as if we're debugging our live Azure instance, but we're doing it on the safety of our local dev box. If I need to instrument performance behavior, I can enable profiling, and then the Visual Studio Profiler will actually sample data or instrumentation, which I can pull down and learn about hotspots in my application's performance. So I've enabled IntelliTrace, I've chosen all the options, I can hit Next, and I get a final summary of all of the target deployment options I would like to have. For more advanced users, note that we have a Save button here where we can save each of these Azure environments to a profile, which is an MS Build file that you can use at a later time. I'll hit the Publish button. This will kick off the build and deployment pipeline. So at this point, we will build a cloud service project, we'll build all the constituent files, and we'll connect to Windows Azure to upload and actually publish this into Windows Azure. And the great thing is this is a task that has some latency, and the Windows Azure activity log works with you asynchronously to show you the status of your packaging and deployment as it's happening, and you can continue to do work while you're waiting for that to be done. While this application is publishing, let's touch on a few other global tools that will help you with cloud development. When I click on the Server Explorer, we see a few nodes in Server Explorer that are specific to Windows Azure developers. I have my compute nodes. This is where I can visualize actual deployments and actual cloud service environments. I have the Windows Azure Service Bus. This is where I can work with topics, queues, and namespaces in Service Bus, and I can work with those and diagnose those right from Visual Studio. I have Windows Azure Storage, which gives me a lightweight way to visualize things like Windows Azure blobs. And even if I'm working with Windows Azure virtual machines, which are the more stateful, durable virtual machines, I can visualize all those virtual machines right here in Visual Studio, and I get important developer information, like what's the DNS address, which ports are opened up. And as I build an application that mixes our cloud services, PaaS roles, and virtual machines, I have all the tools that help me stitch those tiers and pieces together. So it just helps me take the development process even further. One thing I'll say about the Server Explorer, this is a great asset for all developers. So whether you're working in cloud services or even outside of cloud services and you just want to use a particular service in Windows Azure, you can get at all of those inside of Server Explorer. Another thing I'll call out here is at any point you can import your subscriptions, and that will make your environment aware of what's available and what's possible from Windows Azure. So with that said, I think we had a good tour through how Visual Studio works with you to build cloud applications. We also saw how it plugs in and helps with the application lifecycle management. And with that said, we really appreciate you watching this video and look forward to you actually trying Visual Studio 2012 and trying the latest SDK for Windows Azure. Thank you.